Okay, we're on Algebra 2, Section 2.2, and we're going to be talking about characteristics of quadratic functions. So one of the most important characteristic of a quadratic function is that it is symmetric. And we can talk about the axis of symmetry. The axis of symmetry goes right through the vertex, splits this thing in half. You could fold it in half and it would coincide with the other side. So when we're looking at the vertex form of a parabola, and we know that the vertex is at hk, that means, so if this is hk, then I know that the axis of symmetry is x equals whatever my x value of the vertex is, so x equals h. And now we're going to talk about using symmetry to graph a parabola by hand. All right, our function is the opposite of 2 times x plus 3 quantity squared plus 4. So the first thing we're going to do is identify h and k. In this case, I know that h is the opposite of whatever this is, so h is -3, and k is whatever this is. K is 4. So I know where my vertex is. It's at -3, 4. I know, because a is -2, that this graph points down. So, and I also know that the axis of symmetry is x equals whatever this is, which is -3. So I want to plot my point, and I know that my axis of symmetry goes through x equals 3. The axis of symmetry is always a dotted line, by the way. All right, so now I need to find another point, because I can't just draw a parabola based on one point. So what if I find what y would be if x was -1? So I'm going to plug -1 into my original equation and solve for y. When I do that, I mean, you can look at the work, or put it on pause, work ahead, or work on your own, see if you get the same thing I do. And I end up with y equals -4. So I know that the point -1, -4 lies on the graph. 1, 2, 3, 4. So right here. Well, remember, the parabolas are symmetric. So at this point right here, if I can go 2 units over from the line of symmetry and there's a point here, then I can go 2 units from the line of symmetry in the other direction, and there's also going to be a point here. So I know this one, I know that one. Those are the only 2 I need to graph or to plot so that I can now draw the graph. If you're doing this on an assessment of any kind, I want to clearly see this point and the vertex. I want to clearly see the point that you chose to find. All right? So now we're going to look at another form of a quadratic function. This one is the standard form. ax squared plus bx plus c. And if it's in the standard form, then the axis of symmetry is x equals the opposite of b over 2a. Don't worry about memorizing this right now. We're going to do some examples that will help you understand it. And the constant in this form represents the y-intercept, where the graph crosses the y-axis. And the vertex, if this is the line of symmetry, then I know that this is also the x value of the vertex. And then I would just to find the y value, I would just analyze the function at whatever x value I come up with there. So let's do an example. And let's say we have f of x equals 3x squared minus 6x plus 1. So the first thing you're going to do, and you're going to follow these steps every time, you're going to identify a, b, and c. In this case, a is 3, b is negative 6, and c is 1. And then we're going to find the axis of symmetry. Well, I know that the axis of symmetry is the opposite of b over 2a. Well, the opposite of b is positive 6, and 2 times a is positive 6. 6 divided by 6 is 1. So the x value, or the line of symmetry, the axis of symmetry, is at x equals 1. So now I want to find the vertex. Well, I know that the x value of the vertex is 1. So I'm just going to plug it into f of x and solve for y. And when I do that, I get 3 times 1 squared minus 6 times 1 plus 1. And you do all the math on that. It's negative 2. Oops, sorry. So the vertex is at 1, negative 2. Let's go ahead and graph that. 1, negative 2. There's my axis of symmetry. And usually I like you to label the vertex. In other words, when I ask you to label a point, it means just putting the coordinates right there. All right? But don't forget that if this is in standard form, what C stands for? C is the intercept. It's where it crosses the y-axis. In our sample, in this function, this represents the y-intercept. So I know that it crosses the y-intercept there. Well, let's look at the symmetry of a parabola. I know that there's another point that lies straight across, right? So this would be 1 over to the axis of symmetry, 1 away. I know there's another point right here. And there's my parabola. Does your parabola have to be perfect? Nope. But it should have these 2 points and then this third one that we just put on there because I know it's symmetric. Okay, so we've done one with the vertex form. This one was the standard form. And now we're going to look at the intercept form. I guess we're not going to do that yet. Hang on a second. We're going to do something else first. Okay. One big thing that you're going to have to start thinking about is, because we're talking about characteristics of a parabola. So we're going to talk a lot about finding maximum and minimum values. And with a parabola, we can actually do that. There is a maximum value. There is a minimum value. If you look at a parabola that points down, this is the maximum value right here. The graph will never go beyond that. If the parabola points up, this right here represents the minimum, the lowest value that it will ever be. So if you think about, here's the vertex, right? And this is the minimum value. Well, isn't this the minimum? Doesn't it just represent whatever y is on the vertex? Yep. Same here. If this is the vertex, then I know that the maximum value is y equals whatever that is. The other thing we're going to be talking a lot about is where is the graph increasing and decreasing, and what is this function's domain and range. So if you imagine yourself that you're like a little, I don't know, like a little ladybug. I like ladybugs. And we're going to travel this parabola. We're going to travel this graph, and we're going to start at the very, very farthest at negative infinity. And this ladybug's going to be walking along the graph. So you can see that the ladybug would be going down, in other words, decreasing until you reach this point right here. And then once you get to the vertex and keep going towards positive infinity, that graph is increasing. The ladybug is climbing up. It's just the opposite over here. If you're coming from negative infinity, then you're increasing, and then decreasing. So on this, if I asked you this question on a test, your response would be the function is increasing from, let's see, well, there's a lot of ways you can write it. This is how I would do it. From negative infinity to 0, and it's decreasing from 0 to positive infinity. We'll talk in class about other ways to write that, and you guys can decide. I'm not going to be too picky about that. If you can explain to me where it's increasing and decreasing, I can understand it. I'm going to go ahead and give you credit for that. So let's talk about domain and range. Remember, domain is what x can be, range is what y can be, x and y. If you can't remember this is how I used to remember it when I was in school. D comes before R in the alphabet, X comes before Y in the alphabet. The domain is what X can be, the range is what Y can be. So on every parabola, the domains are all going to be the same. Every parabola that is a function. Why do I say that? You'll find out in the next couple chapters. Okay, because if I look at a parabola like this, there's nothing that X can't be. So that's why we say that the domain is all real numbers. X can be anything. Y can't be anything, though, because this is a minimum value. That means no y's can be below this line, right? So all my y's have to be greater than or equal to whatever that value is. And then if you look over here, it's going to just be the opposite if the parabola points down. The domain is all real numbers. There's nothing X can't be, but all my Y's have to be less than or equal to this Y value of the vertex, because it can't go above that. All right. Now we're going to talk about the intercept form. So this is the third form of the equation of a parabola that we're going to talk about in this section, which will also be the quiz next week. Will be over these two sections, 2.1 and 2.2. All right, so the intercept form gives you guessed it, the x-intercepts. And the x-intercepts are at P and Q. All right. Let's just go get right into graphing an example. So let's say I have this function, f of x equals the opposite of 2 times x plus 3 times x minus 1. Well, I know that this is in the intercept form, so the first thing I'm going to do is ID the intercepts. IDing the intercepts, it's the opposite of that and that. So x crosses the x-axis, or the function crosses the x-axis at -3 and +1. So the first thing we're going to do is plot those intercepts. Now, I want to find where the axis of symmetry is. Because parabolas are symmetric, I know that the axis of symmetry is exactly in the middle of these 2 points. So it would be right there where x equals -1. All right, so I know that the vertex lies somewhere on that axis, and I know that the x value of the vertex is -1. All right, so we're going to just evaluate the function when x is -1. You do that. You can pause this if you want and work along with me and see if you get the same answer I did. When you do the math, you end up with y equals -8. So the vertex is at -1, -8. So remember, I have my intercepts plotted. There's the y-intercept. And now I want to plot the point -1, -8. 1, 2, 3, 4, 5, 6, right there. So when you're plotting a graph by hand using the intercept form, then what I'm going to need are those 2 points in this one. Whereas before, all I needed was the vertex and one other point would have been enough. All right, let's do some word problems. Or just one. Let's just do one. All right. And there are a couple of word problems on the quiz. So let's say that a soccer player kicks a ball downfield, and the height of the ball increases until it reaches a maximum height of 8 yards, and it lands 20 yards away. No, wait. Okay, sorry about that. I had to pause for a minute. All right, let's start back at the beginning of this word problem. So a soccer player kicks a ball downfield. The height of the ball increases until it reaches a maximum height of 8 yards. Oops. 20 yards away from the player. A second kick is modeled by, and then it gives us this function. Which kick travels the farther before hitting the ground, and which kick travels higher? All right, so there's no way you can do these word problems without having a picture. Drawing one, or at least having one to look at. So the first kick says that it reaches a height of 8 feet or 8 yards, and the height is reached 20 yards from the player, and the player is here at the origin where ground is 0. So if this is 20, so is this. That means that this point right here is 40, 0. This point would be halfway between 0 and 40, which is 20, with a height of 8 yards. So that's the vertex. Now what we want to do, the second kick is modeled by this equation. Now, there's actually several ways you could solve this. I'm just showing you the way I did it, because it's the way that just came naturally to my head. I'm going to go ahead and multiply this out, because I want this to look like a quadratic function in some kind of form that we just talked about. Well, this is going to be standard form, right? Where A is -0.008, B is 0.4, and there's no C, so C is equal to 0. Well, that makes sense. If somebody's kicking a ball, the y-intercept will be at the origin, where the ground is 0. So now I want to find the axis of symmetry, because I need to find the vertex, because that's going to tell me the x value of the vertex is going to tell me how far the ball traveled before it hit the ground, and the y value of the vertex is going to tell me how high, at what point was the ball at its highest point. All right, so I know that the axis of symmetry is that x equals the opposite of b over 2a. Well, the opposite of b is -0.4. Twice this is -0.016. If I divide -0.4 by that, I get 25. Let's put it back into the original equation. 25 equals 0.4 minus 0.008 times 25, which gives me y equals 5. That's my maximum height of the soccer ball. So my vertex is at 25, because that's what This is x, and this is y. So my vertex is at 25.5. So if we're looking at, I'm going to write that up here. Second kick, the vertex is at 25.5. So if I compare these two, the first kick went higher, but the second kick went farther. And that's how you do that word problem. All right, thanks for joining me.